Hi, I'm Phil, and today we're going to see what I've done with the Rove Vision AI version 2 kit. And the projects I've been working on have related to using other models, that is AI models created by other people. And I've tried using RoboFlow, not with a lot of success. My latest project is a fan control, and that's inspired by a project already published on the Seed Studio website. So let's have a look at this project. I'll just open it up and we'll have a look at some of the photos of my hardware. So this is the overall fan on my desktop. So you can see I'm using Lego mounted components and Grove components, all connected to a servo, which can move the fan horizontally and has the potential in the next version with the second servo motor there to move it vertically. And we've got a camera, which is a Raspberry Pi camera, and that's connected to the Grove Vision AI version 2. And we've got other components, and we'll see those later on. And it's all controlled with a Xiao ESP32-C3. On the back of the hardware, we can see that the servo motors are controlled with a Grove pulse width modulation 16-channel driver, which is driving those servos. And we're using a carrier, a Grove carrier, to mount the Grove components. And here's our pulse width modulation unit. So let's have a look at what the goals are of this project. We're going to control a fan, and we're going to use the scanning algorithm to detect a face. That is, we're moving horizontally and we stop when we see a face. So the inputs come from the inference box for the X position of my face, and the output, I'm controlling the servo horizontal angle. And what I'm controlling is that we'll turn on the fan and we'll stop the scanning when we've detected a face. So we do a servo sweep, which is horizontal, and we're at this stage only driving one servo motor. We have the potential for expansion, both by having a safety switch, and also we can have a PIR, which switches on if someone's in the vicinity, and then it uses the smart camera to home in for fine-tuning of where a person's face is. So we're using the Grove AI Vision 2, and it's going to track the face and control the position of the fan. So let's have a look at the hardware. So we're using the Seed Studio Xiao ESP32, and for the servos, we're using the Adafruit 360 degrees servo. And for the Grove components, let's just walk through those ones. We're using the Grove pulse width modulation unit, and that mounts into the Grove base for Xiao. So you can see what that looks like here. And the next unit, I've got the push button. The push button is not used in the software, but the LED is used in this particular version. And our fan is a mini fan, and we're using wrappers to mount the Grove components. For our camera, we're using the Raspberry Pi, and this comes in a kit. And the kit contains the Grove Vision AI version 2, plus the camera and an ESP32. So to protect the camera, because this little camera, which is right in the center, the black part, falls off fairly readily. So what I've done is to protect it with a case, a camera board case, and that gives it some protection. Overall, our electronics, we might actually have a look at what the connections are, and we'll just fire up our PowerPoint slides for that. So what we do, we connect our Xiao to a computer using USB, and this is the way that we not only can program and download, but we can also monitor the progress as we're operating our smart fan. So the way we do this, we add the Xiao base, which is the Grove base, and that allows us to connect additional Grove components using these sockets. And there's the first one that I've got here is the push button. So I'm not implementing that push button at the moment in software, but it's there for expansion. But I am implementing the Grove red LED light, and that goes on to port 8. And with another Grove cable connecting to the I2C port on the Grove base, we've got the Grove hub, and we can add a couple of I2C Grove components. And the first one is our camera. So we've got our Grove Vision and the camera connected to our Grove base, and eventually the ESP32. And we add our second I2C controller, and this is a controller for the servo motors. And I've also added the Grove fan has been added. And we'll have a look at the code. So while we've got the code here, we'll go across to the Arduino IDE and inspect some of our code so we can find that. Okay, so what we've got here is the software for controlling our fan. And you can see where it's based on. And version 2 is the additional Grove components that I've added. So we're just walking through the code, and I've got parameters for the X and the Y servo motors, but I'm only implementing the X, or the horizontal one, in this version. I've also got the potential to add a interrupt controller, which I'm not doing at the moment. So the switch that will connect will go onto that. And for this version, I'm setting up the servo motor. And in the loop, it's quite a simple one. We check the inference box, and depending if we're got a position, we'll just go down to that inference box, and we can see that we're reporting the parameters, and we're setting the state values for the X run and the motor run either to be true or false, depending on where we are within the range. Okay, so after we've done that checking, we turn on the motor or turn it off, depending on whether our inference box has found my face. And if it hasn't, we do a horizontal scan. So we'll go down to that direction, the horizontal scan for our servo motors. And if we're not running the motor, we then scan horizontally, and that's how we do it here. And we can also report, when we go down on the bottom, we can have a look at the serial monitor. So it's telling us the angle, the X angle, and it's going through, the Y angle. And when we get X and Y, that's the coordinates of our That's the coordinates of our inference box. So you can see it's come up and found the inference box over here. And so that allows us to debug and monitor our program. And stay tuned, and I'll give you a desktop demonstration. Before I go, I'll give you some of the references. So just over here, go back to our mind map. And overall, the execution, that code is working correctly, and I'm happy with the results. Plenty of things to look at. The first thing is that for the servo driver, you have to have that in the same directory when you're compiling the servo code. So in the future, I'll be adding the safety switch and also adding a control for vertical scanning, since I've got 2 servo motors. So overall, these are the things that I've discovered, and I'm using the SenseCraft AI deployment software online at Seed Studio. So you can actually have a look at that now. This is what these... And the one that I'm selecting is the face detect module. So that's the one that has to be preloaded into the Grove AI. Okay, so stay tuned for a desktop demonstration. Here we have our smart fan, and it's controlled by a computer and a smart camera. So the smart camera is over here. It's using a Raspberry Pi version 1.3 camera connected to a Grove Vision AI. So here's a similar one over here. So the Grove Vision AI is over here, and it's connected via a Grove cable and Grove socket. We also have on the Lego board a light, a pilot light, a PIR sensor, and if we just go behind that, we've got a ESP32 with a Grove carrier, and on the left we have a Grove pulse width modulation servo driver, which is similar to this one here. And all of those devices are Grove connected, and we also have a fan which has a Grove connection, and all of this is on Lego mounts on Lego boards. And we might actually start it up and see how it works. So all we have to do is connect the power. So we now have our smart fan, and it's trying to find my face. So when it finds my face, it will actually turn the fan on. So if I get closer to it, you can see the fan spinning. So now the pilot light comes on, and I'm just moving my face. Okay, so the light comes on, and so does the fan. And the camera, together with the Grove Vision AI version 2, has identified my face.